Hello.
Hi. How y'all doing?
Oh my, wow, OK, I know it's the afternoon, but please give me something. Hello? Yes! All right, hi, my name is Christina Lee, and I'm an Android developer at Pinterest.
And I'm Huyen Tue Dao, and I'm an Android developer working on Trello for Atlassian.
And if you have seen us on stage before, it's probably because you've seen a talk titled The Road to Kotlintown. It's a series that we do. We started the very first talk with Day Zero. What do you do when you see a file for the first time and you want to convert it to Kotlin? And we showed you how to do that. Since then, we've progressed on to other topics. And today, we're going to start somewhere else. It's going to be a little deeper than that first talk was. I'm going to dive into the type system. And we're going to build that through to Huyen's examples with DSLs. So I hope you're ready and buckled in. With that, let's take a look at this diagram. So Svetlana very, very kindly allowed me to borrow this work that she made. It's all of her, her handiwork. But the reason I wanted to show it is because I think it's a really good, useful tool to see the visual representation of the type system in Kotlin. So here you can see on the left-hand side all of your non-nullable types. You have nothing at the bottom, you have any at the top, and then a predictable progression of types in between. Now, all of those are shadowed into the nullable class hierarchy as well. And so if you really, really want to start at the bottom, you have the nothing type, and you can flow all the way through up to any question mark. So this is the general shape, the visual shape of the type system in Kotlin. Now, that was the wrong way to go. OK, back to the IDE. So the type system is cool, predominantly because it lets us do what we want. So I just want to start out, before I dive in, with a note on subtypes. We very often can get lazy in the way we talk about things, and so we might interchange subclass and subtype, and it's really not a big deal in most scenarios. But a type and a class are different. And so in this case right here, you can see that string is the class, and it's also the type, and that's great. But that very, very quickly falls apart when you have things that are nullable. So on this line, we have string as the class, but string question mark as the type. Now, this can fall apart even more quickly than you would expect as soon as you get into collections, because here in all of these cases, we have the class list, and then we have list of a pair of an int of a list of a string as the type. So they are different things. OK. Why do we care at all? Well, I am contractually obligated to mention nullability in any talk I give about Kotlin, so here it is. We get nullability because we have a really solid type system. So this is something you might be used to seeing. We can assign an int to a number because we have that subtype-supertype relationship. Same thing with assigning null to string question mark. But as soon as you try to assign string question mark to string, it doesn't work. It says that the type is mismatched. We don't maintain that super subtype relationship that we need to be able to assign something. So yay, right off the bat, this is useful. We care about it. But there are some fun things in there above and beyond nullability, believe it or not. There's more to Kotlin than that. So you might have seen this to-do function before. It's pretty handy if you want to stub out a function and you don't have time to complete it just yet, then you can do something like to-do. And if you're a curious dev, you might wonder why this works, because you have a return type here, and you didn't give it to the compiler, so this really shouldn't work in theory. If you go in and look at to-do, though, you'll see that it has the return type of nothing, and its implementation is to throw an exception. That's all that's going on here. Nothing too crazy. And we've seen this concept before in lines like this, where we have that Elvis operator, and we take in something nullable, and we say, OK, assign it unless it's null, in which case execute the right-hand side of this equation. And so here, that's throwing an error. And you'll notice the interesting part of this is that we can then go ahead and use that non-null value as something that is non-null. And the reason we can do that is because we can guarantee that that code will never be reached unless it is indeed non-null. Now, to-do has very much the same property, and that's because nothing tells you that the function will never complete regularly. And so here, you'll actually see that we have a warning which says that the code is unreachable. And that's because when we try to evaluate to-do, we know it will not complete. And so we're never going to get to this left-hand side of the equation where we actually do the assignment. Now, looking into any, there's a lot of questions about whether any and object are the same thing. And the answer there is a little bit complicated. So if you do not explicitly provide a supertype to a class, it defaults to any. So you can do something like this, or you can explicitly state it. And what's nice about any for us is that we get this pseudo-primitive behavior. Now, I do that with air quotes because primitives are a little bit tricky. We have a lot given to us, and we don't have the same concept of primitives in Kotlin as we do in Java, mainly because they do a lot of the heavy lifting for us. So here, when I say primitives, I mean things like int, double, etc., that you would know and love in Java as primitives. So you might know that the difference between reference types and value types means that sometimes the interop is a little tricky. Here in Kotlin, we can very easily describe something as int and assign it to something that's any because our type system is contiguous. Now, under the hood, things get a little more interesting. But for you as the end user, it's as simple as this. You're not worrying about lowercase I, uppercase I, etc. Any is similar to object, and at runtime, indeed, it would be an object, but it's pared down to 3 key methods. So you have your hash code, your toString, and your equals. And that's about it. You can retrieve the object from this, but it's pretty much a bad idea in most cases, and so you're going to be told it's a bad idea. You should probably heed that warning. And it's worth noting really quick that any and any question mark are still different types. Like, just because any seems to be this catch-all object, it's not. The nullable type any and the real type any are very different, so you can't assign them in this way. OK, my favorite part of types, like absolutely favorite, has to be unit. And there's a couple reasons for that. I've provided you with this quote, and you're probably all reading it instead of listening to me, and that's totally fine. It's a great quote. I would encourage that. But the TLDR of this quote is that void and unit, they're there to represent the fact that a function is useful only for its side effects. It's not returning anything. It's doing something, and then it's completing. And that something could be hitting the network or writing to DB. It's a side effect. Now, the difference between something like unit and something like void is that void represents the concept that you're not returning anything from a function. Unit is representing the concept that you're not returning anything useful for a function. And that may seem weird and arbitrary, but I promise it's useful. So the default return type is unit. I can leave it like this. I can go ahead and put it in. At the end of the day, you probably should leave it off. You don't need to add this extra verbiage, so why have it? But if you wanted to be explicit, I guess you really could. Now, unit is implemented in a very simple way. It's just an object. And it tries to stay true to that nothing useful thing. It only has toString. There's literally nothing you can do except for print this thing out. I guess that's something useful, but something very small. So because of that, because it's an object like a lot of other things you use in your code base, you can assign it, and it's a type, and that's great. Where it really starts to shine is anytime you use generics. And the reason for that is because it is a type, and so it can be put into that generic parameter in the same way you would use any other generic. So here, say you wanted to do something that was result or error. A lot of times, that result would be returning something. But sometimes just completing successfully is the result that you desire. In that case, it might be true that unit is the value that you're looking for. Here, that's no problem. We can go in and parameterize something and give it unit as this instance parameterization, and that's totally fine. If you've ever tried to do this in Java, you might know that it's not quite as seamless. Can you do it? Absolutely. But you need to go futz with some capital V's and lowercase v's, and then you have to make sure you're returning the type and not using that void keyword. And so things are possible, but maybe not the way you would desire. So I'm not going to go into platform types. I'm going to skip over right to generics. And I wrote a little ditty for you because it's the afternoon and everybody needs a little dose of joy in their life, and it goes something like this. I have no singing voice. A, B, C, D, E, F, G, T is a type param with upper bound NE. Question mark. And so, yeah, I hope that is stuck in all of your heads for the rest of the day. I really do. So if you're singing this tomorrow morning, you're welcome in advance. So what that means is that the default upper bound, if you don't bound a generic, is any question mark. And you can write it like this. You can write it like this. I don't know why you would do this second version. You already get it for free. But what that does mean is that the default assumption is that what you're working with, T, is nullable. And so if you go in and parameterize by T and you try to use it, it's going to yell at you. This is not null. It's not safe. Get your act together. Now, if you want to parameterize something only by the non-nullable type, you can totally do that. set its upper bound to any instead of any question mark. Now we can work with it. We're not getting any of those null-safe errors. OK. Another quick thing to get out of the way with generics is the fact that if you have more than one constraint for it, you move it over to the right side and hide it behind a where clause. So here, before I was typing t_any like this, I don't need to do that anymore. I can now do where t is both an animal and fuzzy. I like dogs, if you can't tell. OK, that brings us to these fun, scary words that nobody really wants to know about, but everybody feels like they should know about. Type erasure. So just like Java, Kotlin has type erasure. Yay! And what that means is that when you are trying to query something like list of int, you're going to get this very helpful error, which says the type has been erased. The reason we do this is predominantly for performance. It's a fact of our world, so we got to get used to it. Now, you may say, OK, that's great, but I still need to know whether this is a list or not. And don't worry, star projections are here for you. What star projection means is that you have no idea what's in that list, or any other collection for that matter. You have no information. You just care about the type of that class. So you can do something like, if list is list star, yay, we're in the loop now. And this, in and of itself, is fine. You know, you're entering this loop under the assumption that you have a list of something. You have no idea what that something is, but it's a list of something. But it can quickly be abused. And the reason for that is because you can go ahead and make casts like this. And the IDE is going to tell you this is unsafe. And the reason this is unsafe is because it's going to succeed at runtime, whether it should or not. You just said, I have no idea what's in this list. I want to use it. And then proceeded to say, actually, just kidding, I totally know what's in this list, let me cast it. And that's problematic. And so it will succeed here, and the reason it'll succeed is that there is no information to prove you wrong. All the information that could tell you that this was a bad idea was already erased. Now, where it's going to come back to bite you is when you actually try to use it. You're going to get a crash, because if you incorrectly cast this, the thing that you think is an int is not. OK. Now, for one of the more relatable Kotlin moments, I bet many of the people in this room, anybody who has used generics and used an interface, has gotten something like this. They wrote their interface. They're feeling really good about their programming skills. They use it. Everything's compiling. And then the yellow squiggle of death appears on the screen. So they go and hover over it, and it says, the type parameter should have out variance. You say, OK, I have no idea what that means. Let's do it. And so you do something like this. And now the squiggle is gone, so clearly we're moving in the right direction, but I have no idea what out means. So hope that's not going to ruin anything down the line. Well, I've provided this little sample playground for you if you, like me, were wondering what the heck is up with out. So here I have t. The only thing that matters about this example is that in one case, I'm using t in a consumption role. I'm passing it in as an argument. In another, I'm returning it in a producing role. And in the third, I use it in both cases. So here, I don't have any modifiers on my generic t. If I go in and add this out modifier, you're going to immediately see compilation errors anywhere we use t in an incoming argument. Now, you might not be shocked to see that if I switch that and use that in modifier, everything in the producing spot is now a compilation error. So cool, you know everything there is to know about variance. Like, you nailed it. Except for, of course, why do we even care where t is used? That's the question that you would want to know. And the reason we care about where t is placed in the functions that we're defining is because it tells us something about the variance of that generic that we're using. If you're now wondering what the hell is variance, don't worry, I'll tell you. OK. Variance tells us how types with the same base type but different type arguments relate to each other. So it's not how A relates to B. It's how foo A relates to foo B. And that's important. Now, you're probably lost at this point, thinking like, oh, what is variance? I don't know if I want to go here. Well, you're stuck in this room unless you want to get up and walk out. So breathe, and we'll dive into it. This is a huge block of code. The reason it's here is for the visual representation of the things that are read on this screen. You can read it if you want. That's totally fine. But this block of code, the significance is what's underlined in red. So here, if you care, 1, 2, and 3 are these simple declarations. Nothing crazy going on here. I just wanted to create an ordering. And now, here are the 3 different types of variants. That first one, invariant, is the one that you probably know and love. So something that's invariant has to be an exact match. You'll see that this is the only one of these 3 statements that's compiling for us. It has to be both 2 to both 2. However, you also have something called covariance. And the concept of covariance means that subtyping is preserved. And so here, if A is a subtype of B, then foo A is a subtype of foo B. You can see this because we still have this invariant case working, but now we also have this line compiling for us. 3 is a subtype of 2, and so producer of 3 is a subtype of producer of 2. Now, again, you're probably not shocked to find out that if we go to that contravariant case, we've actually switched things around. So contra should give you the keyword here, something that's against. And indeed, if A is a subtype of B, we've switched things, so now foo B is a subtype of foo A. What does that look like in practice? Again, this invariant case in the middle has never given us problems. But now, this case, which hadn't been compiling for us before, it is. And it's because we have that switched inverted subtyping relationship. Now, to answer the question that I posed originally, like why do we even care about this? The reason we care about that out keyword is because it tells us that we have covariance. And we can only make this guarantee if the variable is located in a certain position. And this guarantee gives us some things that I'll go into later, but that's why we care, because we now know that it's covariant and that subtyping is maintained. Now, similarly, we care about that in keyword because we know that the subtyping is inverted. And the reason the location matters is that we can only guarantee that the subtyping is inverted if it is used in that consuming position. OK, so getting to that point of why we even care about any of this. Well, without variance, the world wouldn't be a really good place to work as a developer. The reason would be that everything would have to match exactly, and that's tedious and boring, and probably not how you want to write code. So mutable list is something that is invariant. The reason for this is that we read from it and we write from it, and so we're using it in both the consuming and producing positions. Now, you'll notice that if I have a mutable list of string, and I try to assign it to a mutable list of any, it's not going to work. It's going to tell me that that's not acceptable. However, list is something that is read-only. And here, if I try to use list of string and assign it to a list of any, it works. And indeed, if you go in and click through, you'll see that that e parameter is modified with the out keyword. So it gives us extra flexibility while maintaining all the safety that we would want. Now, unfortunately for us, variance is here to protect us from other people. It will do nothing to protect you from yourself. I wish we had something that would do that. I could use it at times, but unfortunately, variance is not the thing that you're looking for. And specifically, what that means is that it applies to our outward-facing API, things that are consumed by other people. Anything that's internal and private, variance isn't going to help us with. So here, I've set up this block of code again. One of these generics is in, one is out, and one is invariant. Now, here I've defined vals and vars that use each of them. Predictably, because a val has a getter, you'll see that this invariant t, it doesn't compile. Now, vars, they have both getters and setters, so you're going to see both the covariant and the contravariant cases start to fail because we're using in the in and the out slots. Now, if I copy and paste that code block down here, and I append all of those with private, the compilation errors, they disappear. This is exactly the same code, only modified with the private keyword. Everything is now compiling. The same goes for functions. If you use all of these different generics in the producing spot and mark it private, it's going to work, even though some of those are covariant, some of them are contravariant, some of them are invariant. Same thing with the consuming functions. If I remove this, like so, we get our errors back. But as long as these are marked private, we're free to do what we want. OK. Now, you might have heard about use site versus declaration site variance. And Kotlin adds this nice declaration site variance that we get to use. And what that means is that we can do something like this, where we describe t, and we have this class, and we also describe its variance. And so we can do something like this, and we're not adding any modifiers at the place that we're actually using this class. But that doesn't mean that you've given up the use site variants that you have in Java already. So here, I've defined some invariant class. And in the normal case, if I have no modifiers on it, I need that exact class. That's what that invariant case means. But I can go ahead and have these use site variances. And now I can get that behavior where I can assign this class of int to a class of number. Likewise, if I use in instead of out, I can assign number to int. So it's worth noting that these correspond exactly to what you already know and love from Java. We have that out modifier corresponding to the question mark extends. We have the in corresponding to question mark super. So why do we have them? Well, or why do you care about them? Again, to drive home the point, JetBrains isn't going to do all the work for us. Neither is Google, unfortunately. And what that means is that you're not always going to get these really handy collections shipped to you, like mutable list and list, which are two different variants of the same collection type, but one has that out projection on it. And so you might need to make your own, because they're not all there for you. Now, speaking of making your own, Huyen is now going to tell you how you can use the concepts that I just outlined to go ahead and build even more complicated things on top of.
Yeah, thanks, Christina. So it's kind of interesting as we go down this road to Kotlintown, roll credits, the title of our talk, we kind of want to move forward from kind of that first few steps of translating Java ideas directly into Kotlin and try to kind of do things in a more Kotlin way, kind of that idiomatic way. And I want to show you a couple of my favorite tools for not just like using the language features, but being able to build on top of what's available to us already in the standard library and the language itself. So one of the first things that I saw and learned that I felt like just exploded my Kotlin brain was lambdas with receivers. So really quickly, lambdas are function literals. They allow you to pass functions as parameters to higher order functions. And so lambdas with receivers are kind of like a special variant of like lambdas. So say you have a lambda with some parameters. A lambda with a receiver is when you take that lambda and take the first parameter of that lambda and give it some special powers. You basically elevate it a little bit. And what you do is you turn that first parameter into a receiver object. Now, basically what that means is that that receiver object has now become the this inside of the lambda. It allows you to call methods on that receiver object without any qualifiers. So I have a little example here. Say I'm writing a game that might be about crafting stars or building bases, right? And say, like, there's different ways I could build my base, right? And I can kind of encapsulate those kind of permutations in building bases as like different lambdas like I have here. Now, I want to actually set up my base. So I have down here my higher order function. And it takes a name, because we always have to name things. And it also takes a lambda that is that build order, that kind of the different way I'm going to permutate my kind of building of my base. Now, what I do inside of this higher order function is I create the base object, I assign the name, and then I go ahead and actually invoke that lambda on my base. So I run all that setup, and then I actually build my base. And this code's fine. It's very straightforward, but a lot of what you might hear when you start getting into Kotlin is about making code more readable and concise. And as you can see here, it's not the most terrible thing, but there's a lot of repetition, right? Base.this, base.that, base.this. So we can actually improve that just a little bit using lambdas with receivers. So when you're actually taking, say, a lambda like this and turning it into a lambda with receiver, you can actually kind of think about it as, again, moving that parameter. So I'm going to move my base object outside of the parameter list and put it in front. Oh, Vim is on.
Sorry, it's always me.
Yes.
Guilty as charged.
This is what happens when you're good friends, but you disagree on Vim. All love to Vim users. So what I've done here is I've actually taken that base object parameter and elevated it, moved it outside the parameter, and given it its special status as a receiver object. Now, this type in front of my lambda parameter list is called the receiver type. And what I can do now also is remove this variable name, because it's not needed, and also remove all those calls to base dot. And as you can see, by changing this to a lambda with receiver, I've actually reduced some of that repetition, reduced some of that visual noise. And when I actually call that here, wait, actually, I need to change this to be to take a lambda receiver as well. And as you can see here, I didn't actually have to change the internal code to make that compile. I invoke it just the same. So again, reducing the visual noise, making it just a little bit easier on ourselves to write a little bit cleaner code. Now, another perk that you get when you use lambdas with receivers, you can now actually call that lambda with a little bit different syntax. And you can do it a little bit like this. So rather than passing my base object to my lambda as a parameter, it's as if I'm calling that lambda like a member function on that object. It's kind of neat, right? So it's kind of cool, this kind of idea that I can actually almost add methods onto an object. But there's actually a little more official way of doing this in Kotlin, and that is through extension functions. So what are extension functions? Well, I highly recommend, if you haven't already, to read Kotlin in action. It's a great book. I'm not just saying that because I'm at KotlinConf, but it's amazing. It's like probably one of my favorite tech books, and it does a really great job of kind of connecting ideas. And the thing that kind of really got me to understand kind of where extension functions and lambdas with receivers fit kind of in relation to each other is there's this little table in Kotlin in action, and it basically compared them as follows. So lambdas are to lambdas with receivers as functions are to extension functions. And it's this whole idea of adding in this kind of special status for a parameter, right? It's like elevating that parameter again to a receiver object status. And that's what an extension function is. You take a regular function, you take that first parameter, give it that superpower to be a receiver object, and you can now call methods on that object inside of that function without any qualifiers, and it becomes, the this inside of there. So how about an example? So say you're writing an app, front-end app, you've got your buddy on the server side, and for some reason your buddy might have been a little grumpy with you this week, and they decided that when you get that callback from the network request, you get back JSON. But rather than getting some kind of clean error message, sometimes you get null, and sometimes you get an empty object. And it's up to you to handle that, or buy your buddy some chocolates or something, just so that maybe they can fix it next week. But for now, you're going to have to write a utility method to maybe handle that and kind of detect when you have this kind of funky JSON. So you might write something like this. Is null or empty object, takes a nullable string as a parameter, and then does the kind of checking using the null safety operator, so we can default if that JSON is actually null, or actually do the comparison to an empty JSON object. And then wherever I'm actually handling this funky JSON, I'm going to call it just like a regular method. Is null or empty object, pass in that JSON, and we're good. So the thing is that one of the things that I'm sure like a lot of us really like about Kotlin is the standard library functions. And these days we get really cool functions like is null or empty, is null or blank, and when you call them, it's like calling a member function on string, even though it's not really. So how can we do this in our code? Well, you can do it with extension functions. So if I go back up here and replace this with something like that. So as you can see, it looks really similar to what we did with the lambdas with receivers. We've taken that JSON parameter and moved it outside the parameter list to the front of that function name. And then we go ahead and just write the expression body as is before. But there's a few changes, right? So something really interesting with both extension functions and lambdas with receivers is that that receiver object can actually be a nullable type. And this allows you to do some cool things like actually checking, is that receiver object null? And also kind of doing the rest of your checking. So that's what I have here now. So I now have is null or empty object, which is actually callable on a nullable string. Now when I'm actually going to call this in my handle JSON method, I just move that parameter out to the front. And now it looks like I'm calling a member function on my JSON string. So a couple of things. Number one, now that I've told you that it's really awesome and you can have nullable receiver objects, you should do so with care. It is really easy sometimes when you kind of use nullable receivers to start obfuscating or kind of swallowing errors that you should be handling elsewhere. So you should definitely use it. Obviously, in a case like this, it's pretty handy. But whenever you're kind of approaching using this, just be careful and just don't swallow errors. Handle your nulls responsibly, as you might hear many, many times from other Kotlinites. Another thing that you might be asking yourself is, are we actually extending the base class? Well, no. So if I actually look at the null code that this generates, you can see that the code that comes out in the wash is basically that method that I had before. That receiver object actually kind of swings back into the parameter list, and that's what really the extension function is doing. But it allows you to add functionality onto a class without subclassing it and without having to have control or ownership over that object. It's really cool. I'm an Android developer now, and I'm an iOS developer. And something I actually miss from Objective-C is our categories. And it's basically the same concept of actually adding extra functionality on top of an existing class. So yay, I have it now in Kotlin. So lambdas with receivers, extension methods. As you can see, they're kind of great ways of being able to call, add these extra member functions, sort of, and do this kind of like little bit sweeter syntax, a little syntactic sugar that we all have a sweet tooth for now that we're all doing Kotlin. Is there any, but I mean, that's great and all, and that's fun, but what can we really do with lambdas with receivers and extension methods? Well, a lot. So it really opens you up to kind of explore different design patterns. And this is something that kind of just really, I learned about this like maybe a couple months ago, and it just kind of got me so excited to start using these more. So I was really lucky. I got to see a talk by Venkat Subramaniam. He is an engineer, an educator, a teacher. He's amazing. If you have a chance, see one of his talks. And he usually talks about like Java and sometimes C#, but he talks about concepts that are absolutely applicable to what we're doing now in kind of this like new exploration of functional programming and everything else we're doing. So this talk was called Design Patterns in the Light of Lambda Expressions. Please watch it. There's a link. And he talked about this pattern called execute around method. So what is this pattern all about? Well, a lot of times when we're doing something, some task, there's a thing we have to do at the beginning and a thing we have to do at the end. And the stuff that we really care about, the stuff that we actually want to focus on, is in the middle. But there's no way that we can't do the stuff at the beginning and the stuff at the end without causing errors. So common examples would be file input and output, right? You have to open that stream, you have to close it eventually, and then all the actual interesting file I/O is going to be in the middle. Or database transactions. You have to open that transaction, do all the fun stuff, but then you have to remember to commit that transaction if you want anything to actually happen. And what I think really kind of made it click for me is this word that Venkat used, which I am using all over the place now. It's like my golden hammer word these days, is ceremony. And that's what this stuff is. It's stuff that you need to do to get something done, but that isn't the focus of what you're doing. You can call it boilerplate, call it ceremony, but it's something, they're requirements, but they shouldn't be the focus. And if anything, it's more just like you just have to remember to do it so you don't get bugs. And execute around method can actually help you with that. And if you think about things like, again, going back to the idea of like input and output streams, in Java land now, before you would have to remember to kind of do a try catch and then finally close a stream. But now we kind of have more execute around method type constructs like try with resources where it does the work for you. And that's like the power of patterns like execute around method. It abstracts away the ceremony and lets you focus on the actual content. But you can still kind of trust that those important things, those critical requirements that you have to do are done. By the way, if you are curious, there is something that you can do like try with resources in Kotlin. It's called use. Please look it up. But OK, so all of these things are actually kind of based on your object being closable. But what if we want to use this in our day-to-day Kotlin writing life? Well, OK, I like heist movies. And so let's pretend there's an API out there that lets me plan a heist. I apologize for the ambiguous ethics of my talk at the moment, but I like heist movies, so we're going to go ahead and pretend this API exists. Now, in my opinion, the important parts of a heist that you have to get done are the planning, right? You have to plan out all the cons and the driving and the kind of safecracking that you have to do. And then you can actually do all that cool stuff, all Ocean's 11 style, really sexy, kind of like to some kind of cool music. And at the end, the most important part is that you have to escape with your loot, right? So there's something really important we have to do at the beginning, do the planning, and there's something important that we have to do at the end, the escaping. But the part that we really care about, the fun part, is all that stuff in the middle, all of like Brad Pitt dressing up as a security guard and like someone creeping through the vent ducts. That's what we care about. Now, here's some code, planning a heist. It's fine. Again, it's straightforward enough. It's readable, but can we make this better? Can we allow ourselves to focus on the fun part? We can, and we can use execute around method to do that. So if I go ahead and write a higher order function that looks like this, we can start extracting away some of that ceremony. So here's my higher order method. It takes 2 parameters, a name, because again, always want to name something. And then it also takes a lambda, in this case, a lambda with receiver. And that lambda with receiver is where all that fun stuff lives, all that focus, all the kind of like the core part of my functionality is going to be. And then inside of that execute around method is where we're going to take care of the ceremony. So we're going to create our heist object, we're going to pass in the name, and then we're going to do that all-important planning that we have to do at the beginning. And then we're going to actually invoke that block to take care of all the stuff that we care about, to actually execute the fun stuff. And then finally, one of the most important parts, we have to escape. We have to make sure we close things off and put a nice bow on everything. And then maybe you print ln statement and say, ha, 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 I made off with your money. And so if we actually want to call that, it might look something like this. So here's what it was before. And then here's what we have now. So as you can see, a lot of things happened here. First, you reduced the repetition, reduced the visual noise, made it a little bit more readable. And again, now we don't have to worry so much about the ceremony. Now we don't have to worry about the boring planning or the kind of scary escape. We can now focus on the kind of being cool and all the interesting stuff in the middle, and we can trust that that function that wraps around this functionality is taking care of that for us, and that is the power of this thing. It allows you to write things that are cleaner, allow you to focus on kind of the most important part of what you're doing, but also make things less error-prone, because you can trust that those requirements that you need are taken care of for you. So I want to wrap up with taking these things just a little bit further and talk about domain-specific languages, DSLs. This is not a day 1 Kotlin thing. It's not even quite a day 14 Kotlin thing, but I think it's a really great example of how you can use elements in Kotlin and build on them and create something truly interesting and truly different than what we're used to in terms of imperative programming and the way we've done things before. So just as a quick introduction, domain-specific languages, they're basically small languages for very specific problem spaces. They're specialized languages. So they can be kind of their own language with syntax in and of themselves. SQL is a really great example. Or they can be kind of small languages written in other general purpose languages like Gradle. Gradle is a build automation DSL, and basically what's really interesting about DSLs is that it can take an API, even the cleanest API, and give it more structure and make it less imperative. So instead of you calling API method after API method after API method after API method, you can fish out the structure. You can fish out that behavior and make it in a really clean, readable structure, much more easy to maintain. And you'll hear words like language and grammar and things like that. But this whole idea of taking something imperative and giving it structure, which I think is really neat and can be really powerful. And you can do them in Kotlin with lambdas with receivers and extensions, and a few other things that I threw in. So I'm going to continue on with the Heist theme, and I'm actually going to do a side-by-side, because we're running out of time, and I want to show you what I have here. So I'm planning another heist, and here is my heist. It's a little more complicated this time. I'm hiring a whole crew, so I'm adding a bunch of crew members. I'm hitting a bunch of different targets, and I'm doing a bunch of different things. And the code on the left is my original code. So again, it's fine. It works. It's fairly straightforward, but again, a lot of the same not so nice things. Repetition, right? And a lot of it is kind of getting lost, right? We're doing all these method calls, all the same calls, the same API methods, all the same kind of constructor calls, and some of the intention, some of the actual behavior might get lost sometimes when you have just a lot of these API methods. So what we can do is give structure, and again, so I'm using lambdas with receivers, I'm using builder objects, I'm even throwing in some infix in there, even though we didn't talk about it. And what that allows you to do is, again, take away the ceremony, put it away, abstract it, and allow you to focus on the structure, the behavior, the cool parts. So I've added a bunch of different things here. I've added lambdas with receivers, so I can do that execute around method, so I can hide some of the ceremony of creating these crew members. I've added some infix, so I can kind of associate properties and objects together really nicely. And I've given it structure. And hopefully, the code on the right is a little bit easier to read. You can see the structure and the behavior in all of the API calls. And I think the point of this and the ability to do these things is, I guess, just being able to kind of take Kotlin and go from kind of these basic foundational things that we've talked about, to go from the type system, to go from generics, to go from lambdas and lambdas receivers and extension functions, and to not just rely on the standard lib, which is awesome, but to also build your own things and to take your code to this much more kind of declarative, much more readable, much more maintainable, less error-prone place. And what's really cool, and if you aren't convinced yet, is if you go look at the standard lib methods, so things like let, if you click in, which you should, it's like the most fun thing ever for me when I click into a standard lib method and see what's going on. When you look at that source code underneath, you will see all these things that we've talked about today. You'll see the cool things in the type system. You'll see generics. You'll see lambdas with receivers. You'll see extension functions. And you'll see how all these awesome tools that we have are built on these things. And not only that, but on the road to Kotlintown, as we're kind of getting away from directly translating Java ideas to Kotlin and trying to kind of think of things in a more Kotlin way, These are the tools that will help you do that. You build on these things. You kind of see what the standard lib does, and you do your own with it. And you can do interesting kind of constructs like this and take your code kind of to a different level and hopefully make that trip to awesome Kotlintown. And I think that's it. Thank you very much. And I guess we have time for questions.
We have a little bit of time for questions. Oh, gosh. OK, you actually have a question. Great. Like, ooh.
Sorry to shock you. With the extension methods, does Kotlin tell you if you have an identical declaration of that extension method in another place?
That's actually a good point because of the nature of how the bytecode gets compiled. You will sometimes run into problems when, so like I said, so similarly with extension methods and things like that, how the decompiled code ends up just being kind of like a Java method or like a Java bytecode with that parameter, you will actually run into kind of collisions when you have like another method with the same name and the same resulting signature. So you do have to look out for that. And then also, just kind of regular collisions when you kind of have things at the same level that have the same name parameters too. So.
This is fun.
I'm scared.
Do either of you have examples of using Kotlin DSLs in production code? And for example, I've seen this with instrumentation testing with Jake Wharton, but I haven't seen any other examples.
Wynn has a great example, and I'm so glad you asked because I've been telling her to open source it.
OK, so it's not in production, but OK, how many Android developers in the room?
Oh, God.
Hi, friends. Hi, friends. So one of my biggest obsessions in the last year has been constraint layout. For kind of the last version of our talk, which is a little more Android-y, so if you've worked with constraint layout, you know that there's actually a programmatic way of creating constraints, which is constraint set. And it's the same thing. It's a very fully featured, wonderful API, but it also suffers from that same thing where you kind of have to call a bunch of methods and it gets really long. I actually wrote a DSL for that, which was really great because once you got the structure in, if you squinted a little bit, it kind of looked like XML. And I think it's true. And it even had like the
full circle.
Yeah, view ID and everything like that. But yeah, it actually was really great. It's not in production, but I'm trying to kind of sneak it into our code base soon. But yeah, Christina's trying to get me to open source it. So I might actually have to do some more polish on that. But yeah, it actually is useful. And I mean, I basically kind of wrote Onco for constraint set, to be honest. So.
But I mean, that's a good example as well.
Yeah, exactly.
People
it's also a very good example. So.
Anko, I don't know how you pronounce it.
Sorry,
I always say Anko. That's a DSL.
Yeah.
So people are using that
for building view hierarchies and stuff. So.
Anyone else? Is like the third one going to be the lucky last question? No, you're free to go. Goodbye, friends.